You've likely chatted with a large language model, an LLM, maybe you use one daily. But what if AI could do more than just, generate text? What if it could actually perceive the world, decide what to do, and then act on its own to solve complex problems without you constantly nudging it? Today, we're doing a deep dive into the secret sauce, the very blueprint of these intelligent systems. Think of it like we're assembling our own highly capable digital assistant piece by piece right here.
Exactly. And our mission really is to unpack the core building blocks and the ways these open source AI agents actually work. Consider this a behind-the-scenes tour. We're looking at how these sophisticated digital teammates are put together, from their brains to their memories, and even the hands they use to interact with the world. We're aiming to translate some pretty comprehensive analysis into clear, actionable knowledge for you.
Yeah, by the end of this, you should really understand not just what these agents are made of, but how they collaborate, how they tackle problems, and maybe why the open source side of things is so important for how they're evolving. We'll explore the fundamental bits, the building blocks, then introduce you to some key open source frameworks making it happen, and we'll definitely zero in on a really critical mechanism called Retrieval-Augmented Generation, RG. You hear that acronym a lot, and the powerful databases behind it. So get ready for hopefully some aha moments that will make you feel pretty well-informed on a topic that's definitely shaping the future. Okay, so let's start at the top. The central nervous system, the brain of our digital assistant we're building. The large language model itself. It's not just a chatbot, is it?
No, definitely not. Not in this context. The LLM inside an AI agent is much more than a static text generator. Within this larger sort of modular setup,
So not just spitting out text, it's doing higher level stuff like reasoning, planning, deciding what action to take. And what's really powerful, you mentioned this kind of dynamic planning, adapting as it goes based on feedback. It can even tweak its own process through reflection. That sounds sophisticated.
It really is. That capacity for metacognition, thinking about its own thinking, evaluating its performance, adjusting its strategy, that's not just a minor upgrade. It's a fundamental shift. It lets these agents learn from mistakes, almost like a human intern maybe, without needing constant handholding. This self-evaluation frees them from rigid scripts. It allows for much more adaptive, resilient AI systems, especially when things don't go as planned.
Right, that self-improvement ability makes a ton of sense. But thinking in the moment isn't enough for a truly independent AI, is it? It needs to remember the last thing said or maybe what happened last week. Which brings us to memory systems. They must be absolutely critical.
Oh, completely. Without effective memory, agents just can't operate independently. They can't personalize things for you. They can't maintain consistent behavior over time. Think about us humans recalling a past chat, remembering how to do something. It's essential for context and building knowledge.
And usually when we talk agent memory, we're talking two main types, right? Short-term and long-term. How do they fit together?
So short-term memory is like a conversational buffer. It holds the immediate context, what's happening right now in the interaction. It ensures the agent doesn't, forget what you just said mid-conversation. Frameworks like LangChain or AutoGen have specific ways to handle this, things called conversational buffers or list memories. They keep track of the recent back and forth. LangChain's conversation buffer memory, AutoGen's list memory, those are good examples.
Okay, so that's like jotting down notes during a meeting. But for the bigger picture, the history across days or months, that's long-term memory. And this is where vector stores come in. Indexing information as embeddings. Can you unpack that embedding idea a bit more?
Absolutely. So long-term memory stores historical data, potentially vast amounts. It's often done using vector stores. Information text chunks usually gets converted into numerical representations called embeddings. Think of an embedding as a unique numerical fingerprint for a piece of meaning. The clever part is similar concepts end up with similar numerical fingerprints. This lets the system rapidly find related information even if the exact words are different. It's searching by meaning, not just keywords. LlamaIndex's vector memory, or AutoGen using ChromaDB for its vector memory, those are concrete examples.
That numerical fingerprint idea helps a lot. Okay, so the really smart part must be how these stored memories actually get used by the agent's brain, the LLM.
Precisely. Relevant long-term memories are dynamically pulled out and injected into the LLM's prompt or its context window when needed. This is so critical because it makes historical knowledge usable without having to constantly retrain the massive LLM, which would be hugely expensive and slow. Now, there is a challenge, of course. As the memory grows, sometimes you pull back irrelevant stuff, noise. Managing that retrieval quality is an ongoing area of work.
Okay, so our digital assistant has a smart brain. It has memory short and long term. But intelligence isn't much use if it's stuck in a box, right? It needs to do things. That's where we need to give it hands. Tools and function calling. This lets it interact with the world.
You nailed it. Tools are the bridge. They let agents perform actions, interact with the real world, go beyond what the LLM itself can inherently do. These tools are often specialized external APIs, maybe a web search API, a database connection, a code interpreter for math, things like that, or even custom functions you build yourself.
And the real flexibility is that the LLM figures out which tool it needs for a given task, and then it dynamically generates a structured call, often using JSON to activate that external service.
Exactly that. It's like the AI analyzing the request and saying, okay, for this, I need the calculator tool, or to answer that, I need to use the web search tool.
Yeah.
And this leads to something really quite advanced. Agents generating and then executing code. They can do this in sandboxed environments, secure little playpens for complex calculations, algorithms, or file tasks that LLMs themselves are often quite bad at.
A secure playpen. I like that analogy.
Secure.
Makes it clear. So examples like AutoGen's user proxy agent triggering code, or Hugging Face's small agent generating Python code. This is real. It's happening now.
Absolutely. And this whole concept is sometimes called executable reasoning. The LLM's reasoning process directly translates into tangible executed actions. This is what really transforms the LLM from just a language machine into an active problem solver. The range and sophistication of its tools really determine how useful an agent can be in the real world. It's about doing, not just talking.
Okay, so it thinks, remembers, acts with tools. But I'm guessing without a clear plan, it might just flail around, right?
Mm-hmm.
How does an agent break down a big goal into smaller, doable steps?
Good point. That's where planning and task management modules come into play. This component is what ensures our digital assistant doesn't just react randomly. It breaks down complex goals into logical, manageable subtasks. It allows it to work towards an objective systematically.
I remember some earlier AI approaches felt very rigid, like make a full plan, then execute the whole plan.
Yeah.
Has that changed much?
Oh, definitely. Modern agents are much more dynamic, much more adaptive in their planning. We still see simple sequential planning, step 1, then step 2, etc. But we also see hierarchical planning. Think of a manager agent that breaks down a big task and delegates smaller pieces to specialized worker agents. CrewAI is a good example of a framework built around this idea.
And then there's this iterative approach, like the React framework Reason and Act, where it kind of interleaves thinking and doing. That sounds really important for dealing with the unexpected.
It absolutely is. Iterative planning, like React or self-refinement loops, is crucial for messy, real-world problems. Agents continuously refine their plans based on the results of the actions they just took. This allows them to adapt dynamically if something changes or goes wrong, like a chef tasting the soup and adjusting the seasoning as they cook, not just blindly following the recipes start to finish. It makes agents much more robust.
Makes sense. So brain, memory, tools, strategy.
Yeah.
What's missing? Learning, right?
Yeah.
To get better over time, it has to learn from experience.
Precisely. Feedback loops and learning mechanisms are essential for continuous improvement. This allows agents to evaluate how they did on a task and refine their internal logic, their decision-making processes, so they don't keep making the same mistakes.
And how do they typically get this feedback? What are the main ways?
Well, there are two main channels. First, integrating user feedback. The agent might ask you to rate its response, or you might flag an error. Simple, direct feedback, like giving a thumbs up or down. But more advanced is self-correction and reflection. This is where the agent itself analyzes its own past actions and decisions to figure out how to do better next time. LangChain, for instance, explicitly uses this idea of reflection, where agents review their own work. It's like conducting a personal after-action review.
That self-reflection part sounds incredibly powerful. But, looking through the materials, I noticed this kind of recurring theme, almost a paradox. Everyone's pushing for more autonomy, but there's also this constant emphasis on human intervention, human-in-the-loop workflows, needing user feedback. What's going on there?
That's a great observation. It is an autonomy paradox. While the end goal might seem like total hands-off autonomy, the reality, especially now, is that human oversight is critical. The sources consistently highlight this. True learning and safe operation often depend on the symbiotic relationship with human guidance and feedback. It's about safety. It's about alignment with human values. It's about continuous improvement guided by us. It's about building powerful systems that are also accountable. It's really a core principle for responsible AI design today.
Okay, that's a really important point. With that foundation set, let's zoom in on one specific, supercritical mechanism, Retrieval-Augmented Generation, RAG. Why is RAG so vital? Couldn't a powerful enough LLM just know everything?
Well, not really. Even the biggest LLMs have limitations. Their knowledge is frozen at the time they were trained, so they can be out of date. And sometimes they just make stuff up. We call them hallucinations, generating plausible but factually incorrect information. A RAG is designed to tackle exactly those problems.
So RAG is like giving the LLM a connection to fresh, reliable information, a fact checker on speed dial.
That's a perfect way to put it. Our agent combines information retrieval, fetching relevant data with the LLM's generation power. It provides accurate, potentially real-time responses by giving the LLM fresh information and factual grounding. Think of it like giving the LLM an open book test using today's newspaper, instead of asking it to rely only on the textbooks it memorized last year. A typical RAG pipeline has three main phases.
Right. First is indexing. This is about getting all that external knowledge ready to be searched quickly, like preparing the library.
Correct. It kicks off with loading data, could be from APIs, PDFs, websites, databases, whatever. Then big documents get broken down, chunking, splitting them into smaller, more manageable pieces, maybe paragraphs or sections. Tools like LangChain's recursive character text splitter help here. Next up, embedding generation, turning these text chunks into those numerical fingerprints, the vector embeddings we talked about. And finally, storing these embeddings in a vector store, a specialized database built for lightning-fast similarity searches.
Okay. Load, chunk, fingerprint, store. Makes sense. Then phase 2 is retrieval. This is where the agent finds the right info when you ask a question.
Exactly. Your query comes in, it gets turned into its own query embedding its own fingerprint. Then, the system performs a similarity search. It compares the query's fingerprint to all the document fingerprints in the vector store. The algorithms are optimized to find the stored chunks whose meaning is closest to your query's meaning, even if the words don't match exactly. Finding books by topic, not just title.
And the final step, generation. Putting it all together for the answer.
That's right. The system takes the most relevant retrieved information chunks, combines them with your original query, and packages it all up into a rich prompt for the LLM. The LLM then uses this combined context to generate a response that should be much more precise, informative, and factually grounded, significantly reducing the chance of outdated info or hallucinations. RAG basically makes the LLM smarter and more reliable for knowledge-intensive tasks.
And the effectiveness of ARG really hinges on those vector databases doing the heavy lifting for the retrieval part. You mentioned a few open source ones.
Yeah, there are several strong contenders. Milvus is a big one. Built for high performance and massive scale, think tens of billions of vectors. It's really geared towards large enterprise applications. Then you have ChromaDB, often cited for being quite efficient and maybe easier to get started with, especially for managing document collections. Phen9s is another. It's actually a library from Meta, Facebook, very well known for its efficiency in indexing and searching large data sets, often used in memory.
And you can even adapt standard databases like Postgres for this. That seems useful if you already use Postgres.
You absolutely can. Extensions like pgvector allow Postgres to store and query vector embeddings alongside your regular structured data. It offers a nice hybrid approach, maybe letting you leverage existing infrastructure. It just shows the flexibility you have in the open source world to mix and match components.
Okay, so we have components, we have RA for knowledge, but how do these agents actually collaborate? Especially if you need multiple agents working on a problem. This gets into agent orchestration and interaction patterns. I bet there isn't just one way to do this.
You're absolutely right. No single best way. Different frameworks approach this differently, and the best choice really depends on the task. Take LangChain, for instance. Its basic structure uses chains, which are great for straightforward sequential workflows. Step A leads to step B, leads to step C.
Simple and linear. But what about more complex stuff, where you might need loops or decisions based on intermediate results? That's where LangGraph comes in.
Precisely. LangGraph, which is part of the broader LangChain ecosystem now, uses a graph structure. Think nodes and edges. This allows for much more complex, stateful, and even cyclical workflows. An agent might loop back to a previous step if needed, based on new information. It's much better suited for processes that aren't just linear.
And then there's AutoGen from Microsoft Research. Their approach sounds really different. Orchestration as conversation. How does that work?
It's a really neat idea. AutoGen basically frames multi-agent collaboration as an ongoing conversation. Instead of defining rigid steps, you define agents with specific roles or capabilities, and they talk back and forth, exchange information, critique each other's work, and iterate until the task is done. It simplifies building complex systems by leveraging this conversational metaphor, like a virtual team brainstorming in a chat room.
And CrewAI takes that team idea, maybe even more literally, mimicking human teams.
Yeah, CrewAI leans heavily into that. It's all about role-based collaboration.
Mm.
You explicitly define agents with specific roles, goals, and even backstories to guide their behavior within a crew. It often uses hierarchical structures, like a manager agent delegating tasks. It's designed to feel intuitive if you're used to thinking about human team structures. These different paradigms give developers options depending on the collaboration style needed.
Okay, let's loop back quickly to the agent's hands, the tools.
Yeah.
How sophisticated is the selection process? How does it decide which tool and how to use it?
It can get quite sophisticated. The LLM is usually central to deciding the sequence of tool calls. Some more advanced setups use a two-step process. First, the LLM identifies an abstract capability it needs, like I need current stock prices. Then, a separate mechanism, maybe another agent or a dedicated router, selects the specific tool implementation, like use the Yahoo Finance API tool.
Ah, so it separates the what's from the how. And the how is usually that function calling, generating JSON to talk to the tool's API.
Exactly. That structured format is key for reliable communication with external systems. And again, let's not forget the sandboxed code execution. It's a powerful tool in the agent's toolkit, letting it run generated code securely for tasks like complex math or data manipulation that are hard for LLMs alone. Plus, developers can pretty easily add their own custom tools into frameworks like LangChain or LlamaIndex, often just by adding a simple decorator to their code.
So it really feels like this shifts the AI from just talking about doing something to actually getting it done.
That's the core idea. This executable reasoning, where the LLM's thought process directly leads to executed actions, is the fundamental difference between these agents and simpler chatbots. It makes them powerful tools for automating workflows and solving real problems.
Now that we've got the guts of these agents figured out, let's talk about the frameworks that help developers actually build them. We've mentioned a few, but they each have their own flavor.
Absolutely. Each has its own strengths and focus. LangChain, as we said, is often called the Swiss Army knife. It's super modular, very general purpose. It has a huge ecosystem of integrations for pretty much anything you'd want to connect different LLMs, databases, APIs, you name it. LangGraph adds that powerful orchestration layer too.
The go-to for flexibility. And LlamaIndex, you framed it as the knowledge architect.
Yeah, that fits well. LlamaIndex really shines when the main goal is connecting LLMs to your own data, primarily through RAG. If you need your agent to be an expert on your company's documents or a specific knowledge base, LlamaIndex provides specialized tools for that data ingestion, indexing, and querying, giving the LLM a tailored library.
AutoGen, we talked about its orchestration as conversation approach.
Right. Its unique strength is enabling complex collaboration between multiple agents through those asynchronous dialogues. It's powerful for tasks that require dynamic interaction and maybe human input at various stages. Conversation programming is their term.
And CrewAI, the teamwork by design framework.
Yep. Designed specifically for building multi-agent systems that mimic human teams with defined roles and hierarchical processes. Great when you can clearly break down a problem into distinct job functions for different agents.
Any others worth mentioning quickly just to sort of show the breadth here?
Sure. Semantic kernel from Microsoft often appeals to folks in the .NET world. It focuses on enterprise scenarios, integrating AI skills smoothly into existing business applications. And Hugging Face Transformers agents is interesting because it heavily emphasizes the LLM generating code to use tools, which makes the agent's reasoning process quite transparent, as you can just read the Python code it produces. Shows the diversity out there.
Okay, so the tools exist, they're powerful. But building and deploying these things, they can't all be smooth sailing. What are some of the big hurdles? Explainability and trust seem like a major one if you don't know why an agent did something.
That's a huge one, the black box problem. If you can't understand the decision-making, it's very hard to trust an autonomous system, especially for critical tasks. So best practices emphasize designing for transparency. Humans need to be able to retain control and understand what the agent is doing. Frameworks are helping here. Like we said, Hugging Face generating readable code helps. LangGraph state management makes debugging easier because you can track the flow. Visibility is absolutely key for building trust.
And security, data privacy. Especially if agents are handling sensitive company or personal info. Can open source actually help here?
It really can. Using open source models means you have full control. You can deploy them locally within your own private network. This keeps sensitive data from ever leaving your controlled environment, which is a major advantage over relying solely on third-party cloud APIs where you might have less visibility or control. Local deployment is a big win for security.
Then there's performance. Running these complex agent setups, especially multiple agents coordinating, must take a lot of computing power, right? Scalability challenges.
Definitely a challenge. They can be resource intensive.
Hmm.
But frameworks are tackling this. AutoGen, for instance, is built with scalability in mind, using asynchronous operations and allowing for distributed setups and caching. LangChain's modularity means you only use the components you need, helping optimize. LlamaIndex uses efficient indexing for fast Argo over large datasets. And those specialized vector databases, like Milvus, are designed from the ground up for speed and scale in the retrieval part. It's an ongoing optimization effort across the board.
And finally, let's circle back one last time to that autonomy paradox, maintaining human oversight. It feels like the more capable the AI gets, the more important the human in the loop becomes, not less.
It really does feel that way, and it's a critical design consideration. As agents get more powerful, ensuring they stay aligned and safe requires robust mechanisms for human control and understanding. Frameworks are building this in. We mentioned AutoGen's human input mode parameter letting you decide exactly when a human needs to approve or step in. LangGraph also supports adding explicit human review steps within a workflow. It's not about preventing autonomy, but about designing systems that are both powerful and responsible, systems we can trust.
Wow, okay. That was quite the journey. We've gone from the basics of what an AI agent is, explored its core parts, the LLM brain, the dual memory systems, the tools for acting in the world. We saw how frameworks like LangChain, LlamaIndex, AutoGen, and CrewAI bring these pieces together in different ways, and how critical RE and vector databases are for keeping them grounded in facts. And we wrestled with that crucial balance between increasing autonomy and the absolute need for human trust, oversight, and control.
Yeah, and the pace of innovation in open source agents is just incredible right now. We're definitely moving towards even more sophisticated, more adaptive, more specialized systems. Expect to see improvements across the board, better memory, smarter tool use, more refined ways for agents to collaborate. But that relationship between humans, developers, users, and these evolving AIs, that collaboration will remain absolutely central to shaping a future where AI really helps us achieve more.
So as you think about all of these powerful, increasingly autonomous systems, here's a thought to leave you with. Given that inherent tension, that paradox between boosting AI autonomy and maintaining essential human oversight and trust, how will you envision using these tools? How can we deploy them to really capture their amazing potential while making absolutely sure that accountability and ultimately human agency stay firmly in the driver's seat in our fast-approaching AI-driven future?